Okay, hello. We're so back. Where should I put this? Maybe let's put this here. Ooh. Does that fit? Yeah, we're so back. Chat, we're so back. I'm so lost. Where should I put this? No, that'll do. It's good to be back. Italy's great. I had a conference. I didn't just leave you guys to go on a holiday, I promise. But I heard you had great fun with not just Henry, but Sophia as well. Did they treat you nicely? More importantly, did you treat them nicely, I suppose? This camera looks bad. One day I need to get a proper... setup. Good. Buongiorno. Hello. We treated with respect. Thank you. That's good to hear. Good. My name's Jake. Jake. I get Jack all the time though. I don't know why. Maybe it's not as common of a name. Well, thank you again. I got to thank Henry and Sophia again for manning the fort in my absence. And I know they did a fantastic job. This is annoying. I'm going to hide this. I know they did a fantastic job. I was watching the lectures, some of them live, some of them the recordings. It was really good to see. Yeah, we have 3 lectures left together. How sad. It goes so quick. Sorry, I'm putting BlissTex on. Yeah, all right. So, what are we going to do today? Well, the good news is we have no new topic really for the entire course. So, we're done. So, if you're sitting there going, I can't take this anymore, please, this needs to end. We are sort of wrapping up, which is really kind of sad. I'll miss you all, but we have no new content. So now it's revision, exam prep. That's really what we're all focused on today. With some exceptions, where's my mouse? For some admin stuff, of course. So I know Henry has given you... the MyExperience spiel, but I'm going to do it again. So MyExperience is incredibly important. I know a lot of people only do MyExperience surveys when the course is really bad or if a course is really good. Sometimes, students only do MyExperience if a course is really bad. It's really important just to always do your MyExperience for all your courses. We get a lot of resources to deliver this course at this scale. So if you have to consider, right, all the help sessions, the forum, we have to pay all the tutors for the forum, we have to pay tutors and lab assistants for every tut lab for 3 hours. We have to pay the lecture moderators that are, Bree, we have to pay John, every single person that makes this course possible. There's so much that goes behind the scenes, and if the MyExperience response drags, not just the quality of the surveys but the response rate, it makes it really hard for us to have an evidence-based discussion around the resources that we need. So it's not just, hey, let's fix bad courses. It's useful for us to say, look, we have this great course, the students have a great time, we need these resources. And also it means that we can take these learnings into future comp courses or engineering courses that you're going to take. Okay, I know I'm rambling a lot, but MyExperience is really important. Please do it. I know Henry's went over this. Yes, Henry, you're formally invited. If we hit 70%, we will do a live stream hangout, maybe play some video games or something. And Henry will be there because he seemed to get a bit of anticipatory FOMO. But again, we're only doing this if we hit 70%. 80%, I don't believe we'll ever hit it. Don't know. So please just do it now. Here's the QR codes. These will directly take you to the survey that you need to complete. So 1911 is the one on the left, 1511 is the one on the right. I think it'll only let you do the one that you're enrolled in anyway. But you gotta you guys, you're not gonna get me with Updog. Please, what is this? Like, this is not my first rodeo. All right, I'm better than that. I'm not shaving my head. Jesus. We can do something less extreme than me shaving my head and more cool than a live stream or something. I don't know. I think one term I said that if we hit 80%, I'll do the Q11 of the exam on stream, but that would be pretty... I don't really want to do that. So, but hit 70% and we'll see. So please scan the QR codes. Do you want me to... I don't really want to wait now for you to do the survey. It really doesn't take long. I'd really rather just get into the lecture, but the response rate at the moment is still like 10% or something. So please do them. Yes? I don't know what anyone's saying. I'm not even going to read that. I don't know what people are saying. I'm lost. Okay. Can someone put in the chat if you want me to wait while you do my experience now? Or if I should just continue? You and Henry should be friends. Henry and I are friends. Okay. Augustus wants me to wait. Oh, there's a poll. Bree's done a poll. What is this poll saying? Should I get the music back somehow? How do I get the music back while I wait? I don't really want to wait. I'll go to the next slide while you're doing the survey and talk. I don't know if we linked this last week. Oh my God, one second, I need to sneeze. Okay, I'm back. Thank you, John. Oh, Henry's here. He's lurking. You linked this video yesterday. Fantastic. Okay, if you need a more fundamental approach to the linked list stuff, go back and watch this animated explainer I made a few terms ago. It took me ages to make it. Okay, we're going to do a few things today. Basically, it's all revision of linked list stuff. We also, if we get the time, we're going to do an exam style linked list question, like a hurdle question. So you saw some of the array style hurdle questions in the practice week 5 exam. This will be a review, an overview of what a linked list style hurdle question is. So then if you can do an array an array hurdle and a linked list hurdle, you are fully equipped to pass COMP1511 or COMP. And so for COMP1911, you don't need to do the linked list hurdle. So we're going to do that. If we get time, Kahoot, and probably we won't get time to do a demo. This will take some time, I think. All right, so that's what we're doing today. Thank you, Bree, for posting that in. All right, am I good to get started, or are you guys still doing the MyExperience survey? For hurdles, does passing the linked array... Let me read that again. For hurdles, does passing the linked list array... linked list and array questions mean getting 50% of auto tests. Yeah, that's correct. So in order to pass each of the hurdles, you need to get 50% in the marks. And so next week, lecture 10, the first lecture, is a proper array exam lecture. So all of those details we will go into detail next week. But yes, the answer is yes. Okay, we're good to get started. All right, so the way we're going to do this is Sophia, I think, started an introduction to this Spotify program. I'm going to do a bit of a review for my own sake on what that code is and to take you all through it. Okay, so there's Spotify.c, then we need Spotify.h. Let's go to code here. Okay, did that move? Yes. Sure. I should have that. All right. Okay. Can you all read this? Okay, I think that looks good. Okay, so we're going to start with a recap of this Spotify source code that Sophia, I think Sophia started or wrote it. Maybe Henry worked on it. I've got, I think, the code as of yesterday. Someone correct me if this code looks outdated. So what we're going to do, we're going to read through this code, get our heads around it, talk about the structure of it, and then I'm going to implement one of the functions that's important but missing, and I heard that some of you were asking for. Does that sound good? So this is a really cool demo use case of linked lists. This is Sophia's implementation for Spotify. So let's start at the top here. There's a few ways that you might break down reading source code that you didn't write. I'm going to take you through how I do it. People might take a different approach. So we start off by saying the standard inputs, standard includes, we don't really care about that. Or we care about it, but it's not too important. And then Sophia's including Spotify.h, which if we have a look at, it is worth always checking the header file for some information. So we have your constants, we have an enum. Okay, there's some genres, that makes sense. We have the struct, the structure here of the data structure. So what Sophia's done is got a definition of a struct called Spotify, and a Spotify struct is a pointer to a playlist, and that's called playlist. So we need to look at what a playlist is. So this is this is like our node, essentially. The node in that linked list has a name, cool. How many songs are in the playlist? Okay, another linked list to each song in the series, and a pointer to the next playlist in the series. Okay, so a playlist, so it's actually a sequence of playlists is Spotify. Okay, so that's our next node. We have a linked list of songs within each playlist. So that sort of makes sense. A song is also a linked list. Okay, a song has a duration in seconds, it looks like. The name of the artist, the genre, the name of the song, and the link to the next song. So this is not a doubly linked list, but a struct that contains a linked list, which contains a linked list. So it's structured that way. So that's why it's important to look through your header files. Also, sometimes there are some basic implementation details in a header file, but it doesn't look like that's the case here. These are just the function stubs for our implementation. So that's great. One way I like to start this stuff is to start at main, which we don't have. So I take it there's a different main file. Yes, there is. This is called main.c. Okay, let's paste that in. So let's look at this main file. All right, so we have an initialized Spotify function. We add some playlists. A playlist is just the name and the structure that we're pointing to. Then we can add songs. So we add songs to a playlist, it looks like. Oh, yeah. So that's one of the playlists. So we add songs to a playlist. We can print the whole Spotify structure. I'm assuming that prints playlists and songs, excuse me. We can remove songs. We can delete Spotify, which I'm assuming doesn't do anything right now. Yeah. Okay, let's run this to make sure this all compiles okay. I don't want to do that. You guys are going to have to remind me how to compile multi-file programs, but I think you do. What do you do? Spotify.c, main.c, is that it? And you don't compile the header files? Dash out to program. Okay. We run the program. All right, cool. Whoa, there's a lot here. So, okay, we're doing some songs. Miss Jackson, that's a great song. You know, I saw Outkast live once. Love Story, I don't know who that's by. Golden, I don't know who that's by. Dynamite, I don't know what that is. Pink Venom, I don't know what that is. I'm Old, Touched, Kyoto, Good Days. Okay, I don't know these songs. Phoebe Bridgers, I know. Blackpink, I've heard of. Is that a group? Is that a person? They're K-pop, right? Yeah. I don't know who that is. Sophia is so young. All right, cool. Then we can print. This is really cool. So we print Chill Vibes. Yeah, I don't know K-pop, I guess. I'm going to have to add some songs to this thing. Okay, Chill Vibes, K-pop hits. Oh, we're going to get banned if I play this music. Okay, so I know. Oh, yeah, Taylor Swift. I know Love Story. Yeah. Cool. And then printing Spotify. So this prints. So what are the difference here? Or did we just, I guess we probably deleted something and reprinted Spotify. Yeah. Okay, cool. Okay, this is great. Oh, we even have a merge playlists function. Let's look at that. I'm really not a Swiftie, I gotta say. Oh, okay, merge playlists doesn't do anything, so that's not done. Print songs of genre is not done. Okay, so these are all things that we could do. I'm assuming Henry hasn't done any of these. I think one term I accidentally opened Spotify on stream and everyone read me like a book. So you can go back and find that. You can find who I'm a stand of. Okay, so what I wanted to do is delete Spotify because we can't leave memory leaks in our program. We know that's a problem. If I run dcc leak check Spotify.c main.c out to program, I can't spell, and I run this program, I'm probably going to get a memory leak warning, which I get right here. So that's because we don't have delete Spotify implemented. So that's what we're going to do today to start off our recap. We're going to look at delete Spotify. So far, it looks like we have a way to delete single songs, right? Single nodes. We know that because there's a delete remove song function. Let me go back to code for a second. Code here. We have this remove song function. So it's given the Spotify structure, given a playlist name, and give us, I guess that's a song name. Probably good to rename that to song name. Find the playlist. Go through all the songs. Bug. This only checks blah, blah, blah. I'm going to assume that that's solved. But while there's a current song and it matches, If there's a current song and the current song matches the name, we delete the song name. So I'm going to assume this works fine. So we can delete a specific song, but we can't delete the entire Spotify structure, which means we need to delete every song, we need to delete every playlist, and we need to delete every genre, I suppose, or just everything that's malloc we need to delete. So this is the job of delete Spotify. We're going to put that in there. We need to delete every song, we need to delete every playlist, and then we need to delete the main Spotify struct that we malloced. Yeah, sometimes you might call this a deep free because you're freeing absolutely everything. So the way we're going to do this is from the bottom up. So we can't just free Spotify, right? Because that would free the Spotify struct that contains all the information, but it wouldn't free deeply. So it wouldn't free the actual memory allocated for the songs, for the playlist, etc. So what we need to do is go through the Spotify struct, go through every playlist, go through every song, remove that, then remove the playlist, then remove the Spotify struct. Does that make sense? So we need to go in deeply, remove everything, and come back out. Does that make sense, everyone? Yes, no, maybe? Thumbs up, thumbs down? Do we know what we're doing? Weird lemon, yes, I think. Cool. All right. So just so I don't spend so long in the lecture getting my head around this, I've done a bit of pre-work. Let me put that here. So what we're going to have to do, it's not too hard, really. We have this remove song functionality, so we may or may not be able to use that. But really, all we're going to have to do is loop a couple times. The inner loop is obviously going to be every song in a playlist. So once we've got a specific playlist, we just need to loop through and free every song, right? The way we do that is really simple, and we've done this many, many times. And here is a starting off point for us. So this is the inner loop. So we say while the current song, so we're going to loop through every song, is not null. So while there's a song remaining in the playlist, we get a pointer to the next song that we can temporarily store. Okay, why do we need to do this line? Now, I know Henry has spoken about this, maybe even Sophia. When we're going through a list of a linked list, and we're freeing everything in the linked list, why do we need to get a temporary pointer to the next song or the next element in the linked list? Yeah, absolutely. Lemon points out, otherwise we lose the reference to any remaining node in the linked list. If we just freed the current song, we wouldn't be able to access current song.next, right? And that is, I would say, catastrophic. Okay, why is that catastrophic? There's actually a term for it. Is it called? I don't want to get the term wrong. I'm pretty sure it's called memory orphaning or orphaned memory. Someone clarify? I'm pretty sure it's called orphaned memory. Correct me if I'm wrong, but it means that we will never have a way to find and re-access that memory. And in a long-running program, that is really, really bad. So we need that temporary, so that we get this temporary pointer to the next song. We free it, and we can then move to that next thing, right? With our current song pointer, we rerun the loop, and we do that again. So this is really quite simple. Some problems here, like obviously we haven't defined next song. That's fine, we can do that. But otherwise we just free the song because the song is a pointer that was malloced. All right, let's look at the outer loop. So that's how we remove every song from a playlist. Well, we also need to do that for every playlist, right, in the Spotify struct. So Spotify has a linked list of playlists. And we do the exact same thing, right? This is like literally almost line for line. We're just doing this at the playlist level. So while there are still playlists to process, get a temporary pointer to the next playlist in the list of playlists, free the playlist, okay, well, yeah, with a caveat. Free the playlist, and then we move the playlist. And this is where we first, remember we said deeply, have to remove every song that was in that playlist. Then we can remove the playlist here. Does that make sense? So this is where the inner loop is going to live. And I'm already thinking about a way we can improve this, but that's fine. Okay, and here's the full code that for now I'm just going to copy, but I will talk about it. Let's go to the code. Can you see that? Yep. So delete Spotify. We're going to just paste it in here. And one too many brackets. All right, so let's run through this. Let's delete that. Deep freeze all memory in the Spotify structure. Goes through each playlist. If there is a playlist, remove all songs, then free the playlist. Then repeat, basically. So let's look at this. Delete playlist. Let's run through this again. First of all, we got to get the current playlist. Current playlist is just Spotify playlists. This is the head of the playlists. We have a temporary reference to the next playlist. Okay, that makes sense. While there is a playlist, right? We got to free every song. So we get the head of songs and we have our next song pointer. The inner loop. So while there is a song, get a temporary reference to the next song, free the song, and iterate. Then we basically do the same thing for the playlists, and then we free Spotify. So that should delete everything. One thing that we could do, we should decompose this. So what do I mean by that? So this is the full completed implementation of delete Spotify. This code to delete a playlist, so every song in a playlist, we can move to this remove playlists function just to decompose it. So I think the best way to do that is to do it. Let's have a think about this, but so here, okay, the intention was that we pass the playlist's name. I actually don't agree. Why don't we just pass in struct playlist playlist. Let's just pass in the playlist. Playlist to free, let's call it. And then we can say, we can have these two. So the current playlist is playlist to free playlists. Sorry, we don't want that. This should be the songs. Okay, the current song, next song. All right. Basically, we just cut all of this. All right. We don't need to do that. Let's think about that. So remove the playlist. We pass the playlist we want removed. We get the current song, we get the next song. Well, the current song is not null. Do that. Free the current song, go to the next song. Once that's all done, we just free. We only have one playlist. We should just free playlist to free. And that should be it. We need to call that here. And then we need to say current playlist is equal to is it current playlist.next? Is that what it was? Yeah, I think so. Remove the playlist. No, I think we need to do next playlists is equal to current playlist dot next. Then we remove it. Then next playlist. Is that what it was? All right. Then we free Spotify. All right. Let's give this a test, I suppose. So I think delete Spotify was already called. So let's just make sure this compiles without the leak check. All right, that compiles. Let's run it. Let's make sure there's no error. All right. I guess we don't call anything when we delete Spotify. Yeah, so let's just do that. Okay, we have no printfs, but let's just printf deleting entire Spotify. Structure. Shout out Spotify. Give us a something. All right. Let me just recompile that. Deleting entire Spotify. Okay. The real way we can test this works is by doing a leak check again. And hopefully, yeah, we get no error. So that worked fantastic. So let's just delete that. We don't really need it. Delete Spotify now works. When we run with DCC leak check, we don't see an error. Why? Because we implemented remove delete Spotify. All right. Can we do a quick poll in the chat, Bree or John, whoever's doing it? If that was clear, if delete Spotify makes any sense. Thank you, Bree. Cool. So that's saved now. So if you go to the live code for this week, you will see this code live synced. The diagram on the PowerPoint slides explained it very clearly. That's great. I don't know which ones you're referring to, but I didn't have any, did I? But yeah, this is really nice. This works really well and it frees everything. There's some other functions here which we could look at doing. I think Henry did merging, printing songs of a genre. Like, it's all pretty straightforward. Oh, there is something, right? I think delete Spotify if it's in here. No, remove playlist. Oh, it's not in the header file. Remove playlist. Oh, it's called delete playlist here. That's so funny. Here it was defined the way I was going to define it. But so let's call it delete playlist because it's called delete Spotify. That should be delete playlist. Yeah, okay, cool. Let's just make sure that compiles now. Great. That's a bit nicer. Cool. Oh, something fun for you guys. Who remembers the Splashkit content? Does anyone remember that? I think there were some labs on it, and I think it was a secret, or not a secret stage, but an extra credit stage of assignment 1. So in in Splashkit, if I go, what am I doing? Do I have web browser? Chrome. What does that do? Nothing. Let's fix this up. Chrome. Here we go. You probably can't see all of that. Okay. Here, if you go documentation, if you go to audio, you can do play music. And you can actually, like, you could include Splashkit here and actually play the songs if you've got the MP3s or something. So all you'd have to do is go load music first. You give it the file name of the MP3 or OGG file in your directory. Give it a name. So this sets the name of the resource. And then you just do that. And then you could just do play music. And you could do with the name that you just loaded, and you would just play the string, like play music, like you would pass in the string that you're loading in this program, and it would play the songs, like actually play it out of your speakers. That would be really cool. It'd be like 4 lines of code to add that basically. And then you just free the actual MP3 resource. I don't know if you can use MP3. I think it's like OGG or something. That's the only thing. Anyway, there's lots of details here. There might even be like audio. No, so there's not like a. Oh yeah, here we go. Getting started with audio. You could look through here. There you go. There's all the information. So you can play MP3s. I don't know how we got the license for that, but anyway, there's a bunch of resources here. So you could actually get it to play sounds. Anyway, that's a bit off topic. Let's go back to code. Okay. So let's look at the results of this poll. How do we feel about deleting? Very good. Okay. A little confused. Very confused. 9%, 3%. All right. So that's looking pretty good. If you're unsure about how Delete Spotify is working, I recommend whiteboarding it. That's really important. Okay. Oops. What did I just do there? Okay. Here. But most of you look like you got a decent understanding of it, which is really, really great. Is there anything else I want to point out about this? Just remember, this part is the important part. You deep free. So you got to go in, remove the smallest things first, then you get back out, delete that, then get back out and delete that, do all the structure. So it's like a depth first search free, basically. So very good. Is there another function which we want to play with? I think I ruined the formatting of this when I reinstalled that extension, but let's ignore that. Playlist duration. Oh, that's really cool. Genre to string. Yeah, that makes sense. Printing a song. That makes sense. That's all there. Printing Spotify is there. Finding a playlist, I guess, by a name. Yeah, that's a string. Adding a song makes sense. Creating songs. Cool. No, that looks pretty good. I would leave print songs of genre to you. Then the only other one is merging, which I've lost now. But I think Henry said he did it. So that leaves us time to do other stuff. Okay, I'm going to get a Kahoot up. Okay, it's making me log in again. Great. Guys, while I do this, if you've got any questions about linked lists, Spotify, just ask your questions now. I'm just going to get the Kahoot loaded. Then we'll do that. Then we'll have the mid-lecture break. And then for the second half of the lecture, we're going to do exam-style linked list questions. Okay. Here we go. Let me make sure that this is reasonable. Edit. Cool. Okay, this looks good. Let's just give everyone a bit more time. Okay. If I unlink every node of a linked list and relink them all in the same manner, is it the same linked list? I think yeah, it would be, right? I don't know if you're getting philosophical intentionally or if you're asking, but the memory would be in the same location of memory. All you've done is unlink it and relink it. So yeah, that would be the same linked list. Okay. All right, let's save this. Let's host it live. Close that. Go to Chrome. All right, let's start it. Yeah, exactly. I'm a person. Okay. I'm getting pedantic now trying to fix this. All right, let's go. All right, I'm going to start. Ready to go? Let's give one more person a second to join. Okay, let's... Oh, no, get out. All right, week 9, lecture 2. All right, linked lists are a fixed size data structure. What do we think? Fixed size data structure. Yeah, false. Absolutely. The whole point of a linked list is that we can efficiently add and remove nodes. Therefore, it's not fixed in size. It's dynamic, right? So it's up there with dynamic arrays as one of our dynamic sized data structures. For the 5 of you who said fixed size, you know, I always say this, but it is worth like, did you just misclick or did you misread? Double negative got you. But if it was a conceptual problem, like type it in the chat, like let's have a discussion. Don't just, you know, make sure you understand why you got that wrong. Okay. So this is just based off time really now. Wingazelle, happy hamster on top. Let's go. What will this function return for this list? 3, 5, 6, 7, 8, X. Surprise. Oh, what is this? Struct node code. I was reading that myself. I don't know what's going on here. I think X is meant to be null. If I read it that X is meant to be null, I starts at 0. While current.next is not null, so it's going to loop for 1 minus the length. So 1, 2, 3, 4. 8 will be current.next is null, so it won't count, so it'll be 4. Yeah. That was a bit, I don't know if it was quite clear that X is meant to be null there. Most people put 8. How'd you get 8? Talk to me, guys. I'm going to need some... Why did you put 8? Tell me your thinking. What? No, blue was the most answered, and you put 8, right? That's the amount of people that picked the answer. Mixed up the index and data. Forgot to account for I++. You thought it was returning 8. I see. I got 3, so I rounded up to 4. Well, good guess. Does my explanation make sense as to what's happening here? Let me give you like my quick, the way I think about this. When you see current.next is not null, okay, instead of current is not equal to null, you always, and you have a classic current is equal to current.next, you always know what? It's looping until the second last element, okay? Why is that true? Because if you're on, like, just look at it. If you're on element 8 and this is null, the next node is null. So then this fails. So it will never reach there. Current will never be 8. So whenever you see current.next is not null, you know you're looping 1 minus the size of the linked list. So 1, 2, 3, that means there's 4 elements. 1, 2, 3, 4. In this case, it's returning I. So it's returning the count of elements that iterated, so you know it's 4. If this was current.next is not null, right? It would be 3, so on. If it was current is not equal to null, it would be 5. And 8, 8 is just the last element. So this was a good question because it had 8 there. All right, so the 8 of you that said 4, I'm getting confused with indexes and values, but okay, wow, that really screwed around with the leaderboard. All right, so remember to pay attention and learn those tricks, like, not tricks, but like those patterns. So what will this function return for the list X? Okay, so this is an empty, so X is null, so there's nothing in the linked list. So head directly just points to null. This is a great question. I really like these questions. Oh, guys, fantastic. I'm so glad. Okay. Can one of the 25 of you who got that correct explain why this is a runtime error? So 4 people said 0, 4 people said compile time error. That's kind of reasonable-ish, but you should know that there's nothing wrong with the compilation. 3 said null. Why is this a runtime error? Nothing comes after the null. Yeah, so you're exactly right, Limes and Jack. We know that null is getting passed in. So it's fine here. Current will point to null just like head does. You start an iterator, that's fine. This is the problem right here. Current is null. And you're trying to, when you have the arrow, you're dereferencing null, and that's an error. You can't dereference null. And then you're trying to read this property next that just doesn't exist on null. So it's this component here, when it's evaluating this expression, it won't even check that, it won't even get to the check because it can't do this. So this is a runtime error because there's no data there. Why can't it be a compile time error? Because technically it's possible that something happened to the memory and current doesn't point to null, and head, you could pass in a real pointer here, and so there's nothing syntactically or wrong with the program. And yeah, as Henry is saying, one of the things you always need to do is your guard checking. And so in classic ones with linked lists this is like really with anything in programming, you do 0, 1, and many. So what if there's nothing in the linked list? What if there's one thing in the linked list? And what if there's many things in the linked list? And this is actually really useful for just lots of things, right? So same with arrays, same with like functions. Like if you got a number as input, what if I pass in like a negative number, 0, 1? That's called like boundary checking. These you learn these ways of thinking, but also whenever you see current.next in a linked list, it's a red flag that you've missed the empty linked list check, because this will always have, anytime you see this and you don't have a while current is not null or while head is not null, you're going to have this problem. So yeah, exactly right, Wunther. You need a if statement here that says if current is null, and then you need maybe a return statement or something to do. So spot on. But most of you got that, so I don't know why I'm going on so much about it. Henry obviously taught you perfectly. Question 4. What does this look like after the function is run? So 3, 4, 5, 6, null. What does this look like after the function is run? Let's have a quick look here. So current is head. Next. Okay, that was hard to do without the pointer. What's going on here? So we pass in a linked list 3, 4, 5, 6, null. Current starts at head, which is 3. While current.next.next is not null, current is equal to current.next. So we're looping until... So if we get to 5, next.next is null, so it's not that. So we're looping until we get to 4. Okay, so current is going to be assigned the second element. Next.next is not null. And then it will fail. So it'll be 4. Then what we do, we make a new node called boo. Boo is equal to current.next, so boo is equal to 5. Okay? Do we see that? So we stop here. This gets us to the element 4. Then we point to its next, which is 5. We point that... What is going on? Boo is equal to current.next. We say current.next, so 5 points to null, and then we free 5. So this should just print... But how did we get... No, how did we get current.next? How does this point to 6? Oh no, I'm looking at the wrong one. What am I doing? Now I got this wrong. It's looping until 5? While current.next.next is not null. So 3 next.next is 5, it's not null. 4 next.next is 6, it's not null. 5 next.next is null. So it should stop at 5. Maybe I got it wrong. Okay. We stop at 5. Yeah, okay, we stop at 5. We make boo point to 6. We say 6 is null. 6 is null. So 5 should point to null. Yeah, okay, so it's grey, blue. Yeah, yeah, cool. It loops until the second last node and then deletes... Yeah, and then deletes the one after it. That's correct. So this is kind of like it's kind of a weird function because... Oh yeah, it's just removing the second last node. Anyway. Still a lot of you got it. You did better than me on that one. I don't know why I was doing this. Guys, I'm so jet lagged. But that's not an excuse. I'll do better. All right, there we go. Question 5. 2 more to go. What will this code output with a linked list 3, 4, 5 null and 6, 7, 8 null? So we've got 2 linked lists getting passed in. Ah, nice. Okay, this one I got. I should play the Kahoot. You guys should make a Kahoot for me. Maybe that's what we can do if we get 80%. Yeah, it's green. Good. Some of you said red. What have you done there? You've done 3, 4, 5, 6, 7, 8. So you've just done it in the wrong way round, I suppose. Current 1 is equal to 3, 4, 5 null. Head 2 and current 2 is equal to 6, 7, 8 null. We loop through current 2 first. So we go 6, 7, 8. We get to the last node because x is null. And we say that its next is now pointing to head 1. So that would be 3, 4, 5. So it should be 6, 7, 8, 3, 4, 5 null. And that's what we have here. If you got red, don't feel too bad. You just did it in the wrong order. Okay, that didn't really touch the podium. And the final question, what is the best data type to replace mystery in this function? Ooh, interesting. So this is the return type. Head is the head of a pointer for a linked list. Post condition, the function has done some manipulation of the linked list and the last. And the list might have a new head node. Okay, this isn't too bad. And I know Henry was telling you all about why we return head from all the linked list functions, which is fantastic. Yes, very good. We always return a pointer to head, which so we know that this is going to be a struct node pointer. Why do we do this? Why do we do this? I know Henry spoke about it. Was it yesterday? Why is it important most of the time, not all of the time, that we return back the reference to head? Or aka that we don't manipulate the head reference? Yeah, exactly right, Jay. In case head changes, if you manipulate the head reference, the head pointer, to somewhere else in the linked list, and you haven't stored a copy of it, you will lose the position in memory where the head of the linked list begins. And therefore, you can't reference it again. So for example, like you might need to delete the head node in a linked list and start the head at the second node. But if you don't have a reference to it, like you need to return that new node back, for example. So head might completely change. It's not always that you can just refer to it back in main, because it might really, really change. You might free it, for example. What else have others said? So that we can keep something free, that we can look at the linked list as a whole. Yeah, not free, wrong word, but yeah, that's right. If we manipulate head, we could lose the rest of the data. Yeah. The way to think about it is if you remove the head node from a linked list. So if you keep your reference to it down in main, what will happen if you refer to it later? Can someone tell me? So if I remove the head node, like let's say I've got remove song, and the song is the very first song in the linked list, and I free that song, and I don't return back the new head, the main caller has the head node. Of course it's got it because it passed it in, but what's the problem? What's the problem? Well, wouldn't the main function still had the old head, so it could just traverse the linked list again. You've now lost the rest of the list. Yeah, you've lost the linked list, but yes, Jay's got the answer I was looking for. Maybe, Jack, your answer is correct, but I just can't process it at the moment. But head will point to a freed memory address. That's exactly right. And then when you dereference it, for whatever reason, in a future function, you will be dereferencing freed memory, and that will crash your program. And so we just return the head node, whether it be the same value or an updated value from every function that manipulates a linked list for consistency. We return it back and then we reuse it. So that's why our code, for example, here, we don't care about when we delete everything because we're deleting everything, right? So we don't really care about that. And printing again doesn't manipulate. So it's only when we manipulate linked lists. So adding a song. Okay, well that's actually, why is that just got a return statement there? But that's not a good example. Okay, these don't seem to do it, actually. Which is quite funny. But, well, how are these working? Create song returns a new song. Add song. I suppose, yeah, adding, you don't need to do it because you're just adding. Delete song, might need to do it. Remove song. That's also void. What if you delete the head node? This only checks and moves the head if it's the only node. Oh, so yeah. Does this bug still remain in the codebase? I think it does. Removing a song. Oh, because you've got the playlist. So it doesn't really matter in this case. I think. Yeah, because you're keeping the parent node. You're never deleting the parent node because it's in the playlist or it's in Spotify. So in this case, this is a nice way. Does that make sense? Because this. So playlist always has songs here. And songs then points to the first song, right? So it's fine. There is another solution to all of that, but let's not get into it. All right, let's see what happened with the Kahoot Chrome. Okay, third place, Green Kitten. Second place, Stella Raccoon. And first place is Majestic Possum. So make yourselves known. Take a screenshot of your podium. And next week, our final in-person lecture, I'll give you a Pokemon card. Cool? All right, congrats to everyone though. You all did really well. I'm really glad. Let's go back to slides. I'll quit this. In fact, let's go on our break. I'll be back I'm going to set an alarm for 7 minutes. And we'll do some exam linked list questions. Guys, I have a confession. I didn't start the timer. I have no idea how long it's been. Someone tell me. Can I get a timestamp? No. We still have 3 minutes, 0 minutes. Regarding the exam, do we have access to any custom bash commands we've written? Interesting. Yeah, well, the answer is still no, but interesting question. Then you could write anything and keep it in a bash command. Okay. Break was supposed to end at 12:15. All right, well, I can wait 2 minutes. That's fine. I'll keep my word. Okay. Some feedback I got from assignment 1 was to not use break. What is a good alternative? Okay, that's a great question. Okay, hopefully no one minds if I just do just talk code stuff, basically. Yeah, it's like you'll get more feedback, but let's talk about it. Well, Ben, if you've got some code from an old lab that uses break, if you send it, we can do a bit of a code review session. It's not that there's an alternative to using too many breaks. It's just the way that you structure your code, you're doing it in such a way that you need to break more frequently than you should. It's better to not need to. Why is it better to not need to? Because anytime you've got control flow altering statements like break or return, you need to keep track of what that does to the control flow. So let me explain. The problem with assignment is I don't know if we've given out solutions yet. So I can't look at assignment code yet. So I better not do that. But so let me just explain though. So the problem is, So let's say you loop through every linked node in a linked list. So you say while current is not null, current is equal to current.next, blah, 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 blah. If you look at that, you can say, okay, this iterates through every node in my linked list. Let's say you've got while current.next is not equal to null. You say, okay, well, I know what this does. This loops until the second last node in my linked list. So when you're looking at this, you can glimpse at it and see what it does, right? And I was doing that in the Kahoot questions, and we do that in the program when I was looking at Sophia's Spotify code, which I've not seen before, really. So you're looking at it, you can get an idea of, okay, what does this code do? And I can trace it. But if you've got break statements or return statements in that logic, you can no longer do that. Does that make sense? Because you then have to understand every condition in which you might break or return. So you can no longer glance at a piece of code and know what it does because you have control flow altering statements. And while you may be able to understand a single break or a single return, now imagine a function that's got 3 break statements. That's pretty tough. So it's just about it's more than readability. It's like, can I look at that code and quickly understand an abstraction of what it's doing? You might not know every single detail, but we have these clues sometimes. Like we have these, like, let's have a look. Like here, while the current song is not null, current song is equal to current song.next. So I know, okay, this is going through every single song, starting at the songs in the first song in the playlist, right? But if I had something like if something, 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 then break, I can just no longer do that. Whoops. So it's not just readability, it's like interpretability. Brown has got an excellent example. In fact, like it's so good, I might just like code it up. So we got int main void return 0. So you say, well, what is that? Go away. Well, what is this? So you could say, let's say our condition is if, how do I turn that off? If some condition, okay, I need to turn that off. How do I turn that off? Why has it started doing that all of a sudden? Features, Copilot. How do I turn this off? Disabled. I don't know if that was it. So if some condition in the bottom right, I don't have that, do I? If some condition, you know, something, 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 break, it's still doing it, whatever. Or it might be like, yeah, break. And then, oh, well, we can actually just use this. So these two are like equivalent, let's say, but here we put the condition in the loop and we don't use control flow altering statements. So when you look at the while statement, you can read the condition of the while statement and understand what the intention of the while statement is. If I look here, I can't do that from the while statement. There could be other things here. I need to scan down, read this. It just makes our life harder. So it's not to say you should never use break, right? That's also, you can't swing too far in the other direction and write really complicated code because you never want to use break. There are examples where it's less code and more interpretable just to use a nice break statement here or there. So it's not like never do something, right? These are soft rules. But if you've got more than one or two, especially in like multiple places within a program, it's a sign that you're relying on it too much. Break it down and think about what's my actual condition here? Can I encode what that break was trying to do somewhere else? Okay, let's go back to slides. Slides here. All right, so exam style linked list question. So this is really cool. Don't worry about, I know you can't read this. I can't even read it. Here. Ooh. Don't look at that. Okay. I'm just going to paste that into VS Code. All right. Exam style linked list question. So what's going on here? So there's a bunch of code here that I just copied in. What's going on? So the great thing is, and this was the first term that we ever did this, is that you've done the week 5 practice exam. You'll know that you get some starter code, and that's what this is here. So this is, can you see my screen? Yeah. This is actually a real past linked list hurdle question in the exact same format that we give in the exam. And this is an example of what we'll do, except in the exam you get an actual sort of question with more detail. So here we're just going off the starter code, but that's good enough for us. You always get given starter functions with do not change. So like obviously do not change this code because we actually drop in the real code when we test your questions. And you get given everything else you can sort of manipulate. So obviously the actual question would be like, this is the goal of the question, this and this and this. Like that's fine, but we can sort of just read this now and interpret what it's asking us to do. Maybe someone can actually find me the actual question for this question starter code. But let's have a look at this. So the function name is delete div6. Delete div6 should delete the first node that's divisible by 6. So I'm assuming we get a list of integers, which is true. So we have a linked list. This is like the most simple linked list you can have, right? Where we're just storing int data at every element. If there are no nodes divisible by 6, it should return the list unchanged, which basically means we return head here. Cool. So that's essentially what we got to do. Go through every integer in data and find the first node divisible by 6. So we need a way to check if it's divisible by 6. Okay. If there are no nodes, return the linked list unchanged. We can look at this code. So we have a way to print it. The main should okay, so we get some information from argc and argv. When you see this is all this is doing is setting up the way to test the function. So basically don't worry about it. Like this is just means some data will be passed into head. And we print in the new deleted variant after our function. String to list, let's not worry about it. This just takes the data from argc and argv and turns it into a linked list. And this is our printing. And you can see it's pretty straightforward. But you don't really, there could be some weird funky stuff in here. You don't need to really understand it. You just need to know roughly what's going on. So this is a pretty simple function. This would be the first linked list hurdle. And it's kind of straightforward. So we need to go through every node. We're doing a classic search here, right? So, right, because we're searching for the first node divisible by 6. The very first thing I would do is set up my linked list search. And by that, I mean, let's go through every element in the linked list. So how do we do that? Okay, how do we loop through a linked list? You guys tell me while I answer some questions. My code is haunted. Yeah, it seems it. Blah, blah, blah. Do we have command line argument questions in the final exam? So questions might use command line arguments exactly like this, but I don't think we have any questions in which you need to do anything with command line arguments. There could be an exception, and that exception is Q11, where all bets are off, right? So basically in Q11, we can ask you anything that we've looked at. Are linked lists 0 indexed or 1 indexed? Interesting question, Liam. The answer is neither. They're not indexed at all. The reason arrays are 0 indexed is because there's actual syntax that allow us to access each element, and that the 0th element is the first element. But linked lists don't work that way. All you do is have a reference to the first node, which is the head pointer, and there is no index. Does that make sense? But if there's an answer, the answer is 0. Like we always 0 index our elements, but that question doesn't really make sense in the context of a linked list. So you might need to clarify what it is that you're asking. Okay, so Lime, set the current pointer first. Yeah, absolutely. Absolutely. Struct node current is equal to head. Okay, now we are deleting here. Okay, we're deleting data, so there's some really good thoughts already. If we would typically say current is not null, but since we're deleting a node, should we use current.next? So again, whenever you're doing something that's manipulating a linked list, think empty, one, many, right? That's the trick. So what if it's an empty linked list? What if it's a one item linked list that's divisible by 6? And what if it's many items where one of them is divisible by 6? So this is what we'll need to think about. Yeah, unleaded, that's a funny, unleaded 98. Linked lists are more like manual arrays. If there's an indexation system, you're describing it, and that's pretty much correct. Oh, Liam, oh yeah, I got it now. If we're trying to insert by index, yeah, the answer is it's up to you. Yeah, it's up to you as the designer of the structure and the functions to decide what is the meaning of insert at index 0 or insert index 1, and as long as you communicate that to your users of your functions, then that's fine. There's no specific answer to that specific question. Okay, Ben's got something. While current.next is not null, current.next is it. So blah 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 blah. Okay, But okay, so let's do this. So let's think about if the linked list is empty. I like doing my guards first. So if current is equal to null, alternatively that could be is head equal to null. It should be exactly the same because current is equal to head. So empty case. What would I return here? What would I return? Yeah, I could return null or I could return head. It really doesn't matter. This would be is unchanged. Like head was null when it was passed in. So when it says it should return the list unchanged, if none are divisible by 6, we're also assuming nothing is divisible by 6. Thank you. So we can just return null, or head, or even current. So that's our empty case. Great. We need to think then, what if there's one element in the linked list and it is divisible by 6, and we need to understand if there's many elements in the linked list, and one of those is divisible by 6. So the problem is if I could do while current So we could do while current.next is equal to null. So this will get us to the second last element. Yeah, because current next. This will get us to the last element, right? Yeah, this will get us to the last element. So this will check every element. Oops. Yeah, not equal to null. Thank you. That's just a typo. We can say current is equal to current dot next, maybe, and we need our if statement. So if current dot data. Now, how do we check if an integer, so data is an integer, is divisible by another value? So there's a really quick trick we can implement. You should probably know it by now. Yeah, absolutely. So Lemon, do you want to explain what that's doing? Whoops. Yeah, modulo. Yeah. So if there's nothing left over when we divide data by 6, that means it's a whole whole division, and it's divisible by 6, which means it's divisible by 6. Right? So if data was 7, there'd be 1 left over, right? But when data is 6 or 12 or 18, then we get 0 left over. So that means we're divisible. We need to free it and remove it from the linked list. Okay? Will that while loop check the final node? We'll check that in a moment. Let's just handle this. Yeah, that's right. So we know we need to free this data. We need to free current, but we need to rearrange the other elements in the linked list. So what I would do is just say struct node temp is equal to current. Is equal to current.next. Free current. No, because we need a reference to the one before it. So maybe this should be current.next.data. Yeah, or we need previous. So there's two ways to handle this. We can have a previous node, or you can actually delete one after. Is there a benefit to one or the other? Both work, but let's do, I think previous might be a bit easier. We can do this actually. So current is equal to blah blah blah. When we loop, we carry current is equal to the current.next, and we say previous is equal to current. Yep. All right. So we need to do that free current, and then we need to say previous.next is equal to temp. Okay, that should be it. Once that's done, we should just be able to return head. All right, how is that looking? We might need to whiteboard this a little bit. Current starts at head, previous starts at head. We can, well, we might be able to improve this a little bit, but let's not worry too much about it. If current's null, do that. We might, maybe we can improve this. We can do this. We can start the one over. No, we can't do that. Let's not do that. Let's not get too clever. Okay. All right. Think empty. So we've done empty. Think many. That's many. Now think one. So what if there's only one element in here? So head won't be null. So we'll come here. Current.next will be null. That's right. So this won't run. So this won't work if there's only one element in it, I believe. Is that right? Yeah. So we could say if there's only one element, if current data mod 6 is equal to 0, we just need to free current and return null because there's no longer any element in the linked list. So 0 case, 1 case, and then this will be the many case. So that should handle that. All else here, we should return head, basically. You could also do that in, yes, most of you are right. You could manipulate this so that it handles the one case. I really like doing it like this. And they both return once, so you know if you get here, you have many elements. Like I just like working this way. It might be a bit longer, but it should work. Okay, we return back head because, okay, why do we need to do that? If there are many elements in there, but none of them are mod, right? Then we just keep looping and we return the unchanged linked list. All right, so the other really important part, so you write a function like this. Okay, we need to see, first of all, it's worth seeing, like, does it compile? So DCC, let's clear this. Exam linked list dash out to program. It compiles. So you'd be able to just run the auto tests. Right now, I don't have any of that infrastructure. What about if the last element is, oh, that's a good question. What if the last element is divisible by 6 in a many case? So let's think about that. Well, I was going to say, well, why don't we actually run this a bit with some code, and then we can just test it. So I think what I can do is if I just do like 1, 2, 3, 4, is that right? Or maybe 5, 6. /. Okay, so that looks like it's, yeah, it's printing it here. So it looks like maybe, yeah, maybe you're right. Maybe it's not actually deleting the last one. If I do 7, there we go. So 1, 2, 3, 4, 5, 6, 7, it deleted 6. If I just give it 6, it should print null. That looks right to me. If I go 6, 6, it should just print, oh, that's an error. So we need to think about that. What if I do like 2, 2? That's fine too. All right, so there's something happening with, it could just be 6 and then anything is an error. Yeah. So that's one problem. 6 and then anything, or the last element is 6, 2, 3, 4, 5, 6. These two have cases. So let's just say like something like this. So we don't have only one element. We have multiple elements. It looks like it's all about deleting the last element. So I would like to whiteboard maybe, but maybe this is okay. So let's say we're doing 6, 6. All right. So current is equal to head. So here, while current dot next is not null, so that's correct. It's not. We do division by 6. This will be true. So we say temp is equal to the next node, which is this one. So that's fine. Temp is now pointing to here. We free current. Oh, and there is no previous. That's the problem. Previous was also pointing to head. So this is the problem. We freed the head node. Yeah, I agree. I think this should be null, but previous will still be null. So the problem is, I guess we could just add an if statement. If previous is equal to null, then we just need to say head is equal to temp, I believe. Temp is the next, yep. And then we can just say else like that. Okay, whoops. Let's see if that worked. I need to recompile. Okay. There we go. So that solved that problem. So this is just thinking through your edge cases, right? So the edge case was that if it's the first node, there's no previous. Well, we can just add a statement to check for that. If the previous state was null, then we can just set the head to now point to the next node. If that's not the case and it was a previous, then we need to rearrange it that way. So the other case, so that's this one, right? So that should just have 6 in it, sure. And then this was the other one that had that I think this just wasn't deleting the 6. So the last node isn't getting deleted. So let's think through this. So here, while current.next is not null, so the problem is 5.next will be 6.next will be null, so that will fail. So this might need to be changed so that it just checks current. once you've exited the final loop, can you just delete current.next node? I don't know what you mean, Lemon. Don't know what you mean. So I think we need to loop while current is not null, because we need to do something to current. We could do something at the end, but that doesn't seem right to me. So this is better. So while current is not null, in fact, that could just solve the whole problem. I don't think we need to change anything. 1, 2, 3, 4, 5. What if we just have a single element? That should be empty. What if we have 6, 6? That's got 1, 6. Okay. What if we don't have any, like a single element? It's not 6. 1, 2, 15. Cool. We should probably check something that's not just 6, like 18. 1, 2, 15. The 18 was removed. So this is looking pretty good to me. 24. The 18 is removed. What if I've got another 6 here? We don't want that to be removed. That's not removed because remember, it should only be the first node divisible by 6. Because you've generalized the setting of previous.next is equal to the temp. Yeah, that's right. Yeah. And previous otherwise equals to current. Yeah. So I think this does a good job. What you would need to do in the real exam is just run the auto test. I don't think I've got the auto test handy, and it will go and do a decent job of testing all the edge cases. And then you would submit the program and move on. And this is a linked list hurdle. So as long as you scored more than half, 50% of the auto marking, right? So you could miss an edge case or two and you would still pass the hurdle. So there are hidden auto tests only because we don't want people hard coding solutions. Like you could just say, if something return this, if something return that. Like we don't want that. But the hidden auto tests, they're not like super hidden gotchas. They're just like a different set of the public, like the accessible auto tests. Does that make sense? Use it for life. Yeah, and then the other thing to remember is like, let's say I did something here, like, let's say I did this, and I recompile, and I run that. Let's say, what was the case where that was a problem? Was it just like something like that? That's not a good example. Let's say I did, I don't know, like this. Whoops. Recompile it. I'll get an error, right? And all I did was like, I made one tiny mistake. Like instead of doing head, which is what it should started, I always just started to null, right? So you might fail every single auto test mark and you would get 0 out of 12. But we're not, we're here for you. So for the hurdle questions, a human being like myself or one of the tutors will go through and they'll say, oh, I see. They got a 0, but it was a typo or something really small, and we'll manually override your mark back up to like a 10 or an 11 in this case, because you would have passed everything, right, if you didn't make that small mistake. So we will also manually go through and try and find you marks. Let's say there are 3 hurdles for linked lists. Do we have to pass 50% on one of them, or do we need to pass 50% on all 3? So there's always 2 hurdle questions per topic, one for arrays, one for linked lists, and you just need 50% or to pass in either one of them. So you need to pass the array hurdle if you're a 1511 student, and one of the 2 linked list hurdles. And if you're a 1911 student, you just need to pass one of the array hurdle questions. So will the auto test cover all the edge cases in the exam? I guess you mean the public one, and what you're really asking is, will the public auto tests cover all the edge cases of the hidden auto tests? There could be 1 or 2 like slight differences, but broadly, especially for the hurdles, yes, they're the same coverage. But it's not exactly the same, like Brianna is saying. We're agreeing with each other. So you can get 60% on one, 40% on the other, and you'd pass the hurdle. Yeah, that's right, random. So you can get 60% on, let me go back to full You could get 60% on array hurdle 1, 40% on array hurdle 2, 60% on linked list hurdle 1, 0% on linked list hurdle 2, and you would pass the hurdles. Can 1911 students pass the linked list hurdle and not array and still pass? No. No. I mean, it's just basically a race between Brianna and I, but you put the exact same comment. Yeah. You guys just have to pass the array hurdle. So focus on getting one of those up to passing marks. It won't be too hard and you'll be okay. But then, of course, you can get your marks from the linked list question, Augustus. So you still want the marks. It's just not a hurdle. Yeah. All right. Don't forget, everyone, that this code I just wrote, it's in the weekly lecture code base, right? You can go and get that code, which means you can even access that during the exam. So we're giving you a lot here. Don't worry. Will we be giving practice exams? Absolutely. You'll hear more about that on Monday next week. Yeah, next week you will have a final practice exam. Now, okay, maybe I'll talk about that now, although I'll talk about it on Monday. So you'll be taking in the week 10 lab, we will give you a full practice exam. These are the same types of questions that we ask in the real exam. Every single term without fail, people tell me that the practice exam was easier than the real exam. It's not true. You're just not as stressed. Or the other reason is people don't take it in exam conditions. So you don't have access to the internet. Don't use the internet in week 10 during the practice exam. Does that make sense? I'm telling you it's psychological. Like we literally pull the questions from a pool of questions that we use to write the final exam. When do we book our session for the final? You'll get contacted about your slot for the final exam by the exams team. There's no past questions with auto tests, but there's auto tests on the practice exam. The week 5 practice exam was something new for us because we didn't know how it would go. Because you've missed, in the real exam, you've had, another 5 or 6 weeks to practice content. It was more just to get you used to the topic. You do get man in the exam. Yeah. Okay, cool. All right. If you've got any more final questions, happy to answer them now. Otherwise, go through the content. If you think you couldn't do this delete divided by 6, you really want to focus on getting in a good position to pass the hurdles. So go through it again, try and write it yourself. You can always come up with similar questions, like that do something different, and try and solve those. And then again, of course, next week in the lab, come along, we will give you a full practice exam and if you should be focusing on the hurdles, focus on the hurdles. But I've got a whole lecture on the exam prep for next Monday. And then next Tuesday is a really fun sort of like end of term bonus lecture. Yeah, no sidekick, no DCC help. Nothing that contacts the internet, but you get man. So you could do man ls, for example, and get information just on how the command works. That's what we mean by man. Yeah, and you got normal DCC. Yeah, that's right. And you can do leak check, for example. Like, you get that. All right. Don't worry about the exam. We got a whole week of preparation for it next week, including in the lab, in the lectures. It's going to be great. You're going to be okay. Just practice, just study, stay cool, and you've got this. Thank you all for today's lecture. I will see you on Monday, hopefully less jet lagged, for our last week of lectures. Stay safe. Good luck with your exam prep. I know that'll be kicking up, and good luck with assignment 2. Don't worry about lecture feedback anymore. Can you just link the MyExperience, please, Bree? That's what we're all focused on. In fact, let's go back to the code. Let's go back to the slides. Let's go to the next slide. Here they are again. If you haven't done it yet, please give it a scan. It'll take you 5 minutes. Okay. It'll take you 5 minutes. Please do the MyExperience survey. Appreciate you all. I'll see you Monday in person. Come along. It's our final lecture. Well, final in-person lecture, and then I'll see you on Tuesday. See you, everyone.